Okay, guys. So let's go back again to my screen and let's continue where we left last class, okay? Last class we were talking about 3D arrays. So there was a kind of a, not assignment, but practice test for you guys. So I will go back with what we call panel data. So panel data was an array. I think the first one was income. The second one we said is savings. We have 5 years of information, so each year is, each row is a year, and then we have three individuals, correct? Okay, and what was left to be solved were these questions here. Yes, years, individuals, income, and savings. Perfect. So how do we select, how do we create, let's say Q1 equals only income. So I just want this screen, the first matrix. You tell me, guys, how do we do that? Let's call this Q1. It's going to be what?
Oh, yes.
This one?
Yeah.
Yeah,
So you want just incomes, right? So it'd
right.
be um panel underscore data colon one for the first array only. So everything for
Exactly.
all individuals, all 5 years, but just the first array.
Exactly. Do you agree with that, guys? Okay. Each. I will not print this one here. No, Q2 was information about individual two in a matrix form. So what we want is individual two only. I want the income and the saving of individual two for all the years. Got it? And we can call this Q2. So Q2, I am going to focus, it's going to be a matrix, right? And I have two columns. I just want, so this is the one that I need to work. So I just want individual number two. So individual number two, so I want all the years for individual number two, right? So I'm just focusing on individual number two. And I want first the income and next to it, the savings, correct? Okay, so what we can do is do you agree with me that this is the income of individual two? What I need is just to put next to it its savings. So I can do a comma or simply a space. And then what I will do here is number two. Make sense to you? Okay. So this corresponds to individual number two, income, the first column, and savings, the second column. Q3, information for all individuals, but just years 3 and 5. So I want to keep the array, but just years 3 and 5. So Q3 is going to be equal to what? So the data comes from here. What I want is only years 3 to 5, right? And everything. I can use this end here, guys, or I can use the size of panel data, comma 1.
So does start also work? If I know it wouldn't work because we want 3 to 5, but is start also a thing like end?
Start, no, no. The start is no, so it doesn't work. You need to put where do you want to start. There is no start command. Okay, makes sense to everyone, guys. So here we have something new that is the end, or you can replace. Remember, guys, as more programmatic you make your program, better. Of course, I can put 3 to 5, but better put 3 to n, so at least n is controlled automatically. Or you can do size of panel data 1, for example, just number of rows. Okay, so let's go to the next one.
Could you hear
Q4.
me? Sorry,
Yes.
I have a quick question. It's 3 and 5 or 3 to 5?
No, it's
So three,
3 to
four, five.
5. 3 to
Okay, got
5.
it.
3
Got
to
it. Thank
5.
you.
Okay. If you want to do years 3 and 5, how do you do that, guys? Let's call this A. I just want years 3 and 5. How do I do this?
What I did was the brackets and just 3 space 5, but I don't know if
Yeah,
that's
yes, this is
fine.
correct. So what you do is 3 space 5, this one here. So this tells MATLAB exactly what column, sorry, in this case, what rows you want to select. Okay, so what I'm doing here is 3 and 5, not 3 to 5. 3 to 5 is this way. Okay. So what is next? Q4, percentage saved per year for all individuals. Okay, so that was easy, right? So this was Q4. Q4 equals what, guys? I simply want to know the percentage of what's saved per year per individual. So how do I do it? I will select this one here. Okay, so I want everything, right? I want all rows for all individuals. How do I compute the ratio savings over income?
Then you would do 2 just to get the savings, and then you would do a dot divide, so like dot
Exactly.
slash,
It's
and
element by
then
element, right?
yeah, then panel
Oops,
data. Yeah, yeah.
whatever. Sorry. So it was everything to everything, comma 2. And I can copy this one here and divide it by 1. Yes, it's element by element. So that's why we have dot divide. So we continue. Q5, percentage expenditure. Oh, we have done this, right? Oh, expenditures per year for all individuals with respect to income. Aha. We need to compute, first of all, expenditures. I can do this in a single run. Do you agree? So what we can do is, let's use the same as before. But what I need to do here, guys, is first I need to compute the expenditures. So how do I compute the expenditures? The expenditures are equal to what? Income?
Uh, one,
Yeah.
yeah, it would just be whatever you don't save, you spend.
Yeah,
So income minus savings.
exactly. So what I need to do here is my income minus my savings. Remember that addition and subtraction is element by element. So I don't need to do dot minus dot plus minus savings. Agree with me? Yes or not? So these are my expenses, is what I have, what was my income divided by my, what is this one here? No, sorry, subtracted. I subtract from income my savings. So this is my expenditures and divided by my income. Everyone agrees with me?
Could you just do 1 minus Q4? I mean,
1 minus,
oh well, oh we
no,
we 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 remapped Q4, but
yes. Because remember, savings are in dollar terms, so I cannot do 1 minus. Well, oh, yeah. 1 minus the savings multiplied by the income. Yes,
okay,
yes,
okay,
correct. 1 minus Q4, you mean this one here. 1 minus this one here, for example, is going to be 65% multiplied by your income. This is your expenses. That's correct. If you use this one here.
yeah, okay.
Okay. Makes sense to everyone? One of the annotations here, guys, that you need to realize in economic terms that now we have this famous K-shaped economy or economy. This is based on this basic idea, basically, guys. So what happens is if the more you make, the more you make money, the more your income is, what happens? Two things. Your savings increase and your expenses decrease. So why this happens? Or at least your savings go higher, so you have a lot of money to spend, more than these guys here. Okay, so this is the basic idea of capital accumulation, guys, or wealth accumulation. Make sense to you? This Q4 and should have, wait a second, this was Q5. This is Q4 and this is Q5, just to keep track of. Do you understand that? Now, in monetary terms, guys, the group number one, so let me show this one here for a minute. You see, in absolute numbers, in dollar values, these are expenses of group number one or individual number one. You can see his expenses continue growing in absolute values. For all of them increases, that expenses increase. What is different is the income. The income of these individuals here, individual number one, is growing faster than the income of the other individuals. Make sense? So that's the way in which wealth accumulates very quickly. The more you have, the more you get. And in this example, guys, when we were discussing about fractional trading, so what was one of the main arguments of fractional trading is basically, fractional trading means the following, guys. If you want to invest, for example, let's say in Tesla, $415. Okay, so if you have $500, you can buy only one Tesla. Do you agree? But if you can buy 1% of Tesla, you can buy 1% of Amazon, you can buy a lot of 1% of everything. So you can make your portfolio in a good way. Make sense? So you can replicate the portfolio of other individuals. So this is the democratization idea of the stock markets via fractional trading. Now, however, guys, remember, size matters. Let me tell you. So the stock market is jumping now almost 15% this year. So if you have $100, what is 15%? $15. Okay. What if you have $1 million and you are faced to the same market? So you have $150,000. Do you see? So capital accumulation works because income that you generate is faster at the very beginning. So you have more income, more savings produce more money, and more money produces more money. So that's the idea. Got it? And this is the economic idea that you need to be thinking, guys. Makes sense to everyone?
Hi, sorry, I just want to make sure for my notes. So,
Yeah.
like for example, looking at individual one, we say that their expenditures is greater at this. This is expenditure first. Q5 is expenditures, right?
Q5, yes, I delete this
Okay.
again. Yes.
Yeah.
Yeah, so give me 1 second. This is Q5,
Okay.
and I will call this Q5A, just to keep track of
Okay.
everything. Yeah, yes.
Okay. And then so from there, the idea that you're saying is that we see their expenditures, like we go from 65 to 70, and because the individual starts with a higher income and thus higher savings, then their
Yes.
expenditures are higher. Is that what you're saying, or am I
Yes, it
misunderstanding?
is.
Okay.
It is. So if you take a look to the income of these individuals, do you see? So in absolute value, the individual number one is the one that spends more money. Do you see? 70,000 versus 55 versus 45. Makes sense?
Yeah.
So apparently this one here is the one that has more expense. Well, he has more expenses in absolute values. But if you see his expenses in time versus his wealth, his income, you can see that this decreases. Even in the absolute value, it increases. In relative terms, it decreases. Why? Because his income has this type of behavior. Make sense?
Got it. Yes, thank you.
And that's something that is very interesting, guys, because what is the problem with this issue? Have you heard about the affordability issue that we have that everyone is talking now? They agree, right? So affordability issue is more or less related to this stuff here. So imagine if you are in group number, you are the third individual. For you, an increase of prices of food of 5% or almost 10% on oil and gas, this is very significant for you. Make sense? But meanwhile, for me, I'm number one. I don't care. I really don't care. Makes sense? So later, guys, in one of the classes, we're going to make a development model that is based more or less on this K idea. The problem when we have this type of K economy, guys, is that the people that have a lot of money and they are competing for goods, they affect everyone in the system. Do you agree? Houses, for example, is one example. So if there is a bunch of people that are competing with very low supply, okay, so what's going to happen with the prices? Prices are going to go up. Now, these prices going up affect who? Not only the guys that are creating the economy, that are moving the economy, but also everyone down. So young professionals, people that just go to the market, etc. So they're going to be facing higher prices. Make sense to you? So, and there are a lot of things that we're going to see. We're going to see a developing model later that you're going to understand and develop, but it's going to be related more or less to that. So you can understand the logic. It's straightforward. Got it? Mathematically easy, right? So let's go to what is this one here? Oh yeah, this is interesting. Percentage of income of individual 2 and 3 with respect to the income of individual 1. Q6, you tell me, guys. So what I do, Q6 is going to be equal to, I always go with this one here. And I can have them in a matrix, okay? So the results are going to be here. Oh. So what I do is income of individual number 2 versus income of individual number 1. So let's go first to that. So income is 1, correct? This is the income of individual number 2, correct, guys? Yes. And then I will put, we have to, so I don't need this one here for a minute. Yeah. So, and I will divide this, I will put this in proportion to the income of individual number 1. Income of individual number 1 is going to be this one. And the second one is going to be exactly the same, but for individual number 3. Make sense to everyone?
Yeah, but could you also just do like what Lauren said earlier, where we do panel underscore data, parentheses, colon, comma, and then bracket 2,
Yeah.
3?
Yes.
Okay.
And
Okay.
then you do so basically what we can do is we can do, this is going to be 2, 3, right?
Yeah. Okay. Cool.
Okay. Questions, guys? It's clear? So here we can see clearly, right? So the beginning was 72%. Salary of individual 2 respect to individual number 1 was 72, but later it became 24%. This guy was 41 at the beginning and 12% at the end of the 5 years. Of course, all these numbers are simply created. Okay, so general questions just to practice several commands on MATLAB. How many individuals do we have in the sample? How many individuals, guys? So my panel data. How many individuals do I have? Individuals are where? Columns, do you agree? So of course, in this case, you know how many do we have, but if you have a huge data set, guys, and you want to know the number of columns that represent, in this case, individuals, the way you find that is basically with size of panel data, what dimension you're looking for. Agree? Okay, so let's go to the next one. How many years of data do we have? Well, I'm talking about now. Instead of rows, I'm talking about, sorry, instead of columns, I'm talking about rows. Finally, how many variables do I have? So I'm talking basically about number of faces, right? No, sorry, 3. income, and savings. Give me 1 second. Okay, questions? Are we all okay? Yep, excellent. So we can continue, guys, and let's continue practicing. So let's do something about that is very useful. You see my screen, right? Let's talk a little about cash flows for 1 second. So cash flows, guys, normally look like this. So a cash flow has 4 components. First component is an outflow. Second component is an inflow. Third component is time. And the fourth component, guys, is interest rates. What we call is I. Got it? So now this I is known, or is gonna, what we are gonna work here is simply compounded interest rate. So basically interest, pay interest. That's what we care about this stuff here. And that's the one that we're gonna be using all the time in this class, okay? All the mathematical models, economic models, everything is going to be based on these compounded interest rates. What is interesting about this compounded interest rate, guys, is that just by understanding this one here, we can understand very interesting concepts like net present value or present value and future values. So help me in 1 minute. So imagine that I have this cash flow. Okay. So let's say 1, 2, 3, 4, 5 periods, 6 periods. Assume that I have here a C0 and I want to know how much money I have at period 6. So first of all, what is going to be my interest at period 1? My interest is computed, guys, as my capital. Also, let's assume that the interest rate for all of them is I, okay? I in percentage terms. So my interest here is going to be I times C0. Do you agree? So what is my final capital? My final capital is going to be C0 plus I times C0. So this is my capital 1. So my capital 1, guys, is going to be C0, 1 plus I. If I do the same calculation for period 2, so what is going to be my interest of period 2? My interest at period 2 is going to be I for my times my initial capital at period 2. Period 1, C0, 1 plus I. So what is the final amount of money I will have at the end of period 2? C2 is going to be what I had at the beginning, C0, 1 plus I, plus my interest, I times C0, 1 plus I. So common factor, etc., I have C0, 1 plus I squared. Agree? So guys, if we generalize my formula, if I generalize my formula, how do you think is going to be Cn, or what Cn is going to be equal to? C, C1, 1 plus I to the power 1. C2, 1 plus I to the power 2. So Cn is going to be simply C0, 1 plus I to the power n. So this equation here, guys, is crucial. It's extremely important. Got it? So if I rewrite this one here in common terms in economics, is a future value, Cn, equals present value, 1 plus I to the power n. And then from here, PV, where is my mouse? from here, guys, PV equals future value divided by 1 plus I to the power n. Make sense? Now, how do you call this I? This I, guys, is called discount rate. Right? So always we use a discount rate as a definition. Now, I will just tell you guys how do we do time transformations. So basically what I'm trying to tell you here is imagine that you have a compounding interest rate for 1 year. Let's say that this is 10%. And what you want to know is what is my interest rate for 1 month? So the formula, guys, here is going to be, it's always 1 plus the interest rate that you know, 1 plus 0.1, to the power that is a ratio minus 1. So the ratio, just remember, the time or the periodicity of the one that you are interested goes up. And down is the periodicity of the guy that you know. So as soon as I want 1 month, this is going to be 1 up, and below is going to be what? 12, exactly. Got it? Can you do one more? Can you tell me, and use your calculators or whatever, 2 months, 15 days, and let's say 2 years.
So for 15 days, are we assuming like 360 days in a
Yes.
year?
So we
Okay.
have some assumptions. Okay, some assumptions that 1 month equals 30 days. 1 year equals 360 days. Okay. So just to be sure that you are in a right dimension, guys. So what goes here? When I want 2 months, what do I need to put in the fraction?
Would it be 212 or 16?
Yeah, 212 here, 15 over 360, correct? And here 2 over 1. And then you get these values here in a very easy way. Just calculator. We're gonna try to do this in math. Okay?
So you've had a question.
Yes.
If we're able to divide it by the days as shown in the 15 days one, why are we not making it 365 still again?
Oh yeah, because this is a banking standard. Okay?
Okay.
Because remember, that's the easy way, but remember, banks don't lose money. We're gonna see this in real life examples that they go to the exact number of days using the 360. You're gonna see that later.
Okay, got it. So
Okay.
in real life, technically banking, they focus on the 360 regardless, right?
Yes. Yes. Okay, because remember, if we go February 28 days, March is 31. So just for standardization, we use these ones here.
Okay, thank you, sir.
No problem. Okay, can you give me these values, guys? Someone. Can we use MATLAB to do this stuff? Of course. Okay. So MATLAB is a huge calculator. So let's say my interest was equal to what? Sorry. Oh yeah, I have interest is 0.1, correct? This is interest 1 year. So I will do interest 1 year, something like that. So my interest 15 days is just a name, guys. It's going to be equal to what? 1 plus this one here to the power, where's my power? To the power 15 divided by 360 minus 1. Agree? 0.004. Do you get this number?
Yes.
Perfect. And so on. So where's my paint? So we know that this one here is 0.004, etc. Make sense to everyone? Okay, so now let's do one example that we're going to start working on MATLAB. So let's assume, guys, you go with me with this example because I want you to understand how the model works. It's extremely simple, but then I want you to implement this in MATLAB. Okay? So follow me for 1 minute. So let's assume that I have the following cash flow. I will do only one cash flow. I have $400 for 1, 2, 3, 4 periods. 1, 2, 3. Let's assume that my interest is equal for everyone and equals 2% per period. Make sense? So what I want is to find C4. Well, in this case, C4 is going to be very simple, right? C4 is going to be 400 times 1.02 to the power what? 1, 2, 3, 4. Make sense? Easy. Now, let's assume the following example. I have my 400 again for 4 periods. But now my interest is going to be changing. It's going to be 2%, 2%, and then jumps to 3%, and then then decreases to 1%. So your C4 is going to be equal to what, guys?
Is it 400 multiplied by 1.02
Yeah,
to the power 2
yeah,
multiplied by 1.03 multiplied by 1.01?
completely right. So, and I will write explicitly the ones here, okay? Because that's what we're doing. Makes sense? Okay, so can you, okay, so copy these ones here and do 1 and 2 in MATLAB and try the following. So let's assume let's assume for now 2% all the time. Okay, and what I want from you guys is I want you to enter I, like I have done in MATLAB here. I want you to enter the variable I, something like that. Well, in this case, it's going to be I simply. And use variables and not only numbers.
So, and then in example 3, is that 250 or 750 you're pulling out?
250. Let's say
Oh, okay.
250.
Okay. Thank you.
Yeah. Yeah. Let's do this 250. Looks more 250. Yeah. Okay, let's say 3 minutes, guys, to do this stuff. I will please remind me to restart the recording. So what do we get in the first example, guys? What is this value?
I got 432 and 97 cents.
Someone to confirm?
I also got the same value.
Yeah, perfect. So what do you get in the C4? C4 equals what? You can create three I's, right? I1, I2, I3. Let's do this. Let's do as you can. Later we're gonna go more efficient. Someone C4.
Would it not be that was I missing a step with that value with the 432? Like this is example one, right?
Yeah. Oh, yeah.
Okay.
This
Yeah.
one is correct. So now this one
Okay.
here, example number 2.
432 and 93 cents.
132, 93 cents.
Yeah.
Someone to confirm?
Yeah, confirmed.
Perfect. Okay, let's do these two and then we go to the last one because from the last one I want to present different methods to do this stuff and the most efficient ways of doing this stuff. So let's go to, where's my lab? Here we go. So let me ask you here. Okay, so what I will enter is, let's say my C0. My C0 equals, it was 400, right? Then my interest was 0.02. And my N was 6 periods.
Oh, switch screens.
Oh, uh-huh. Yeah. You don't see my MATLAB?
No, we see
No.
whiteboard.
Let me stop sharing and let me go back again to, yeah, it should be screens. Now do you see my screen? In MATLAB?
Yes.
Okay, perfect. So what I'm defining is my C0 is 400, my interest rate is 0.02, and my N was 4, right?
You're defining it as negative 400?
Yes. So remember, oh yeah, this is something. Everything that is an outflow is
Oh,
negative.
yeah.
Right? If you conserve everything, if you preserve everything, that's okay. It doesn't damage everything. Okay, so then how is going to be my C4? So this is my data, and my C4 is going to be equal to what, guys? It's going to be C0 times 1 plus my I to the power N. Agree? Guys, agree?
Yeah. Yeah. But I think that's a CO.
Oh, C0. Yeah. Good eye. Well, indeed it's 432.97. Yeah, so basically, if I want to do this correctly, because it's future value, I need to do this one. It's a negative, this part here. So do you get 432.97, etc. So now what is beautiful, guys, when you have these type of things, then you can change I, you can change N, you can change whatever you want. Correct? So let's do the next example. Where's my paint? Next example is 400, but then I have 2, 2, 3, 1. Okay. Are you seeing when I shift from screens, I'm going to Paint and then MATLAB, or you just see MATLAB?
I just saw the shift now.
Okay,
Yeah, I did
perfect. Yeah, excellent. So now I can go back again to my definitions. C4 is 400, Li equals, oh, here I have more I's. I will do that the dumb way, okay? I1 equals 2%, I2 equals 3%, I think. Correct? and I3 is going to be equal to 0.01%. Is this correct?
Yes.
Yes,
Yeah.
and then, yep, and then I can do this in a brute force way. So it's going to be this. Oh, I need to change also my n. Do you agree? Because n, this is a good example. So 2%, so not this one. No, my escape doesn't work. I broke my escape in my computer. So yeah, this one here. So n is also need to change, guys. The 2%, let's call this n2. How many periods in 2%? 2 periods. N2 equals how many periods?
One.
1 period. And N3 also equals 1 period.
Yes.
Okay? You see, remember everything that is repetitive, guys, we can program this in a matrix way. Okay, just take a look to what we can do. 0 point, no, nothing. Oh yeah, because I have put this here. So now I can do the C4 is going to be equal to C0 times what? 1 plus I1 is called I1. Yes, to the power what?
N1.
N1 times, and then I can repeat this one here, right? I2 N2 times I3 N3. Well, I forgot to do the minus here. Make sense to everyone? Now, this is a kind of a, yeah, I'm repeating. I don't want to write in N1, N2, N3. So how can we do this? Can we create vectors, guys, on a matrix with all the information that I need? Can I do that or not?
Mm-hmm.
So I will call date. So I want the first row to be I1, I2, and I3. Got it? And I want the second column to be the ends. Can I do that? Yes or no? Yeah, let's do this manually. So the first one is going to be, it was 0.02, 0.03, 0.01. So this is my first row. My second row is going to be 2, 1, 1.
Sorry, Professor, do you mind scrolling up briefly? I have an error and I just want to check something.
Yeah,
Yeah.
in here,
Yeah, never mind.
I1.
I caught it. Yeah.
Okay,
Thank you.
perfect.
Yes.
Okay, guys, so now I can do my formula, right? I can compute this one here, but this is going to be equal to, how do I call this? Date. And this is going to be useful when we have matrices, when we use programs, so M files. So this is going to be date, first row, comma, first column, date. This is going to be second one. And I will copy this, guys, 1 second, please. 1 plus date. So I need the parentheses here. And I will copy this all the time. Looks longer. It is longer, but it's going to be more efficient in time. You're going to see.
Can we do, sorry, I might be skipping ahead, but dot exponent, does that also work?
Yeah, of course,
Oh, okay.
of course. So let's do this C4A. So what is your proposal, Trevor? Because you see, guys, the thing here, this one plus all this part here is this times this, basically. One of these times this, one of this plus this. Do you agree? So what can I do to do the dot product?
So
So it's going to be
mi
minus C0.
minus
Okay.
C0 times
Yeah.
parentheses 1 plus, like, we want to just select the first row. So that parenthesis, is it 1?
Yeah.
1 comma,
Everything.
yeah.
Okay. Perfect. So
And then,
let me open another parenthesis here, perhaps.
oh,
Yeah.
yeah.
And then
And then dot exponent,
yep.
and then like that second row. Yeah, so dat parenthesis 2. Yeah, okay. Cool, cool. Should work.
Yep. Do you agree? And then what I need to do? Oh, that's it.
Yeah, I think so.
Okay. So can you test these guys? Do you see what we are creating inside these parentheses, guys? Why don't you run first these parentheses and check what we are producing here? When we do the product element by element power, guys, we're going to have a 1 times 3. Do you agree? It's a vector. So what do we need to do with this vector? So take a look to the formula. So what I have done is this, the first one, the first element, times the second, times the third. So what I need to do here, guys, is times another command, the prod of these numbers. What prod does simply multiplies. So you have a new command here, guys, prod. So let me do this step by step for you to understand what we have done. So this one here is simply 1 plus this to the power 2, 1 plus this to the power 1, 1 plus this to the power this. So what I have done is I have built the elements of this one here. And then what I do is what? I need to multiply all of them and then multiply times the original value. C0 times the product of this one here. Make sense to everyone? So finally, this is my summarized formula. Make sense to everyone?
Quick question. So is the product like like that whole the line above that, all of that gets put into product.
Yes, exactly.
Okay.
So all this one here is this vector, do you agree? And then when I say
Yeah.
prot, it's going to multiply each element of this vector. That is exactly what we have been doing here. Do you see?
Yes, yeah.
And that's it. And then you do simply prot of every single of all the elements here, multiply by my initial C0.
Got it. Thank you.
Pleasure. Okay, let's continue. So let's go now to this one. So every time is 2%, but I have two cash flows. And I want C6. Let's say, guys, take 3 more minutes and then we solve it in different ways so you can be familiarized with the ways we can start working with this stuff here. Are you seeing my paint? Yeah, okay, perfect. So
Yeah,
focus
paint.
on this one here.
Was the value we got for that previous one 416 or 432?
432.
Thanks. Yeah, I'm stuck at
Yeah.
416 for some reason. Thank you.
Lauren, I see what you did wrong. If you didn't catch it.
I did manage to catch it. It was a
Okay,
nasty
as a
parentheses,
parenthesis.
but thank
Yeah.
you.
Okay, guys, allow me to solve this by hand. Okay, and then we can get an idea what we are doing. So one way of solving this problem, guys, is very straightforward. What you do is you simply multiply every single value to the future, and then you sum them. Do you agree? So what we can do is 500 times 1.02 to the power 6 plus 250 1.2 to the power 12. Correct, guys? And then you find this value and you find this value, and then you simply sum them, and that's your result. Another method, guys, that is the preferred, that uses the concept of compounding. So what you do is you move the 500 up to the period 4. So it's going to be 500, 1.02 to the power 4. Then you sum the 250, correct? You can do that.
Sorry, if you're writing right now, I can't see, but
Oh, you
otherwise
don't see
yeah.
my paint?
I see paint, but I don't see any like additional writing unless you're okay. There it is now. Weird. All right, thank you.
Oh,
Yeah,
it
it all
is,
just
yeah.
popped
It
up.
didn't load before, yeah.
Really? That's interesting. But okay, so I was telling to you guys the first method is simply you move one by one. Where's my mouse now? Oh, here we go. You do the 500, you move it 1.02 to the power 6, correct? plus the 250, you move these 252 periods to the power 2, then you get these values, and then you simply sum. The other method is you move the 500 up to period 4, so it's 500 times 1.2 to the power 4. Then you sum the 250. You can do that because all these monies are at period 2. And then you move all this money to the power to 1.02 to the power 2. And then you get the exact same result. Okay, so let's do these two methods, and then we do the in MATLAB using vectors.
When changed to 4 instead of 6.
Sorry?
Can you explain again why the exponent became 4 in letter B?
Yeah,
instead
in
of...
the second one. So remember, what I'm doing is I'm moving the 500. So in the second method, what I'm doing is I'm moving the 500 first to here. Do you see? It's going to be 500, 102, power 1, 2, 3, 4 to the power 4.
Okay.
Make sense? And then you sum the 250 to this money, and then you multiply all this money to the power 1, sorry, times 1.02 to the power 1, 2.
Oh, okay. So the full thing gets multiplied to 1.02 to the power of 2.
Exactly, to the power 2.
Got it. Thank you for that, doctor.
Right.
Mhm.
Okay, so let's do this in MATLAB. 1 minute to copy, and then we go to MATLAB. Let me save this stuff. Do you see MATLAB, guys?
Yes, Prof.
Okay, so basically, let's do the cash flow. So my cash flow was 500, then 0, 0, 250. It was like that. 1, 2. No, I think it's period 1, period 0, period 1. And I need another 0, perhaps. So let's check. So it's 1, 2, period 0, 1, 2, 3, 4, 5, and 6. This looks correct or not?
Yeah, it looks accurate.
Yeah.
Oh, I just have a quick question. So
Yeah.
that 250 cash flow, that's after period 4 is like we
It
don't
is
come
at
into
period
period
4.
4.
It is at period 4. So let me show you.
Oh, 0, 1, 2, 3, 4, 5, 6,
Yeah.
right?
So basically
Yeah.
it
Okay.
is, 500. You see my screen? Then it's 0, 0, 0, 250 negative, 0, and 0.
Got it. I was missing that first, like that 0 period. So
Yeah, exactly. And then that's crucial because remember, we start always at period 0. But the
got it.
compounding starts at period 1 because, of course, if you start 0, there is no compounding. To every number to the power 0 is 1. Okay, so that's crucial, guys, for you to understand that the vector way of solving this issue. Let's go here. Okay, so I have my cash flow vector. I know that my I equals 0.02. So let's do first the easy way. And I know that N equals 6. Got it? So now let's compute method number 1, the one that I move piece by piece. So I can call this CC, I don't know, just any name, guys. This is going to be equal to minus CF. What? This is position 1, 1.
But if we had minus already in the vector,
Oh, it is minus already. Beautiful.
okay.
Yes. So we don't need to do this stuff. No. We need it. We need because
Yeah, I
minus
don't.
minus, yeah. Don't
Okay,
stress
okay.
with a negative at this point. It's simply because it's down. But as soon as we're
Got
looking
it.
for the up, needs to change the sign.
Okay,
So that's
okay.
why it's minus plus. So this is my $500 multiplied by 1 plus I, correct, guys? To the power n. What I have defined n to the power n. So this is going to be my first part. And my second part is my cash flow position 1, 2, 3, 4, 5. Position 5 to the power n minus 1, minus 4 already, right? And then I simply sum C6A plus C6B. Do you agree? So let's do it one by one. So of course, it's not, you can do it, but it's not efficient. Now, what we can do is let's call C6, let's say C6C, a single run. So a single run means the following. You simply, this one, correct? So what I'm moving here, so let's say, let's do this to the power 4 plus this is 5. And all these times make sense? Are you with me?
Yes, makes sense.
Perfect. So now let's create something more. Not this one. Where's my? So now let's create something more meaningful. Take a look, guys. Can you do the following? So I want you to build the following. Where's my? I want you to build a vector. Okay, so my vector is going to have, of course, the cash flow. So the first element is going to be the cash flow. Let's call the second element semicolon. So below is going to be the interest per period. And the last one is going to be the power per period. So basically what I want is the following, guys. So my cash flow, I have it already. My cash flow is going to be, my cash flow is 500. What? 1, 2, 3, 250, 0, 0. Do you agree? Then my interest period, I want every one of these to be 2%. And then my, what is that? Power period. Okay, guys. So tell me one thing. The first number is the power is what? For the first element, the power is what?
It's 0, so does it become 1?
No. The power, this one here. So if I want to move the
Oh,
500
okay.
to the future, is to the power 6.
6.
Now,
Okay.
the second one, if I want the second one to the future, how many periods do I need to do? 5, correct? 5, 4, 3, 2, 1, and 0. Make sense, guys, what these numbers are? These numbers are the powers that allow me to move this $500 6 periods ahead. What is the power? Imagine if I deposit here $100 in the last period. It's going to be $100, 1.02 to the power what?
0.
0. And that's why you have 0 here. Got it? So build this matrix. And once you have this matrix, guys, what I want you is to find a matrix way of computing this part here. That is basically, you have it. It's minus 500, 1.02 to the power 6, plus minus 200, 1.02 to the power 2. Do you see? Everything is there. Okay, guys, 3 minutes to do this. First, build in a smart way, okay? Try to find how with the data, how with knowing this information here, how knowing the cash flow, how many periods are in the cash flow, how can I build this one here? How can I replicate these two? And that's it. 2 minutes to do this, guys. First, build the matrix. Okay, guys. Have you been able to build this matrix in a smart way? Because you can do this 2, 2, 2, 2, 2, 6, 5, whatever. You can do that, right? But in a smart way, in such a way that if I change my cash flow, so imagine I don't give you only a cash flow for 6 periods, I give you a cash flow for 10 periods. Everything should adjust immediately. Okay, so that's always your idea, guys, to have something that is not only useful for a particular model, but to be used for many, many different applications. Allow me to continue here. Do you see my MATLAB? MATLAB, do you see this?
Yes.
Okay,
Yeah.
perfect. So I have my cash flow. I will repeat my cash flow. This is my cash flow. Done. So the first row, done. So the second row, I want to be the 2, 2, 2, 2, 2, 2. Okay, guys, here is let me call this I period. There is a new command for you that is called repmat. So repmat replicates whatever you want in between. So how many rows, how many columns? So I want one row, but I want columns to be smart. So what I can do is size of cash flow, what dimension? 2. So what I'm doing is I'm replicating one row. What is the size of 2 is 7 times. Correct? So this is my 2. So what I've done is simply repmat allows me to replicate whatever I want here. It can be matrices also, can be vectors, can be whatever you want. The 1 here implies number of rows, and the size, this one here implies number of columns. So this one here is going to be more efficient in my system, right? If I change CF to have more data, this one here immediately is going to adjust. Make sense to you? Okay, so I have my second row. Now, how do I create a 6, 5, etc. in a smart way using my information that I have from CF in terms of periods? Let's call it power period. So tell me, guys, what if I do the following? I can do the size of cash flow, comma 2, minus 1, because the first one, what is the size? It's 7, do you agree? 7 columns. But I know that I need to start with 1. Sorry, with 6. So that's why I'm subtracting 1. Once I know this, what I need to do is what? It's a sequence, correct? And my sequence is going to be 6, 5. So it's decreasing by 1. And it stops where?
At 0, right?
Zero.
At 0. Exactly. And then we have it. So now can we have let's call M. M is going to be equal to my cash flow, my I period, and my power period, correct? Do you agree? Okay, guys. So what is my cash flow 6? Let's call this C6, C6X, using the matrix now. What if I do the following? If I say M, first row, every column multiplied by 1 plus M, second, everything to the power this should be element by element, right? To the power of, I need another parenthesis here. So what do we get here? M1, element by element product, 1 plus M2 to the element power M2 No, it's not M2, M3, correct? M3. Is this the solution or not? This is element by element. So what I'm doing is I'm using row one, row one, row two with three. So let's do this. So we can try, guys. This is what we're getting. So then what I need to do in order to obtain the final result?
Sum?
Sum. And a negative in front because I'm using negatives, right? So what I'm doing first is I'm doing column by column. What I need is column by column. So this is what is this 563, guys? This is the value of 500, 6 periods ahead. What is this 260? Is the value of this 250 at a 2%, 2 periods ahead. And then basically what I'm doing is one by one, and then you sum. Correct? Yeah, why is two? 823.18 should be the same as the other methods. Questions? Make sense? Okay.
Yes.
Let's create, and you do this very quickly. So what was my cash flow? My cash flow was,
Just CF.
yeah, I want to see the numbers. Yeah. Okay, so guys, let's assume that I have minus 300, 0, 0, minus 750, 0, 0, minus 1000, 0. Okay, so this is your new cash flow. Using the program that you have created already, guys, you need to do one by one. You need to update one by one. Tell me what is your CF? What is your final value? I don't know how many we will have. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12. You need a space here. A space here. Okay, let's do this in 30 seconds. This is my new cash flow. Give me how much money I have at the end of these periods. The interest rate is the same, etc. So build your matrix first. Ready, guys? Okay, so I have my cash flow. What I need is to create my E period. Do I need to do something here, guys? In the formula? Nothing, right? Yes or not? I have changed the composition of CF, but nothing changes here. So immediately I will create 14 periods, 2%. Then I need what is that? My power period. Do I need to change something here?
No.
No. Can I create my matrix? What was the name of my matrix? M. Nothing. It's already there. Can I use the same formula as before? What was the formula that we call it? Let's call it C6X1, just to keep a different one. Do I need to change something there? And here is my answer. So this is a mathematical notation. So this is what? 3,122. We can change the format later.
But going back to the matrix, the second row is all zeros.
Oh, because it is 10 to the power 3. So what we
Oh,
can do, guys, is let's format bank. Normally the format, MATLAB format, remember, this is for engineers, it's format long. Make sense to everyone, guys? Okay,
What
yes.
it ensures that we keep the 2%?
Oh, because I have defined, I told you this is 2%.
Yeah.
E period, this one here.
Yeah. Yeah.
I need to tell you E period, but then in real life it can change.
hmm
Normally, if it's data, it needs to be inputted by hand. Do you agree? But if it's
Yes.
something constant, the program can immediately input this part here.
Mm.
Make
And
sense?
format bank allows it to be constant.
No.
Oh, okay.
No.
Okay.
The format simply take a look to this number here. Trevor
Yeah.
was saying, hey, the second one I know is 2%, but looks that is zero.
All zeros. Yeah.
Yes,
that's what I
but
was
it's not
wondering.
zero. It's indeed e to the power 3.
Oh, okay.
So
And
indeed, it doesn't appear like 0. But this is 0.000002. So two more zeros and one more zero, and the 2 should be here.
got it. And then
So-
our solution, what would that be?
Our
It's that
solution is this
3
one.
point. Okay. Thank you.
3,000, or if you want, let's do as soon as I'm in the format bank already. What is this one? 3,122.01.
Okay. Thank you.
Make sense? Okay, so
Yes,
guys,
thank
can we open now? Let's do I think that we can use this example for a very simple M file. Can you open, please, new? Click new, and will appear something like that. Do you see that? A white. You just go plus. Give me 1 second. I am in the editor. And when you are in the editor in MATLAB, there is a plus sign here. Do you see that? Just click there and appears an M file. Are you with me, guys? So these M files, guys, are the programs, basically the MATLAB programs that allows you to do beautiful stuff in a couple of seconds. You're going to see. Got it? Okay, so how do we start this one here? Always you need to start this defining this as a function. And then the name. So let's call it my cash flow 26. This is going to be the name of my file. And then basically whatever you want. So what is the data? Let's write here. You can write some comments in here, guys. You don't need to do this, but I normally do this just for having this more organized. Here you write, this program computes the future values of a series of deposits. something like that. This, remember, guys, this is simply commentaries. MATLAB is not, it's gonna read this, but don't do anything, doesn't do anything. Then what I can do, guys, I can simply enter a section of data, and my data was cash flow. So where was my cash flow? I want to start this one here. I'm just entering the data, guys. Cash flow, E 0.02, and it was, N was 6, I think. That's all the data I need. Do you agree? Agree? And so what I want is my formula. What was my formula? 6 C6X. No, sorry, I need M first. I need to compute I period. I need to compute how do I call it? Power period. And then I need to compute my matrix M. Oh. Need to create my matrix M. And then I simply do C6X. Then I simply do this. Agree with me or not, guys? So we have the data. Then I have my cash flow. I compute the I period. And it's going to be based on CF, so that's correct. I will compute my power. Then I compute my M. Then I compute my how do you call it? My formula. I will save this one here. Let me save this one here. Save as. So save it where you have all your programs, guys. And be sure that you have this, and then we can play with this one here. Ready? Okay. So how do you run this one here? Well, just copy the title here, the title of the. Just go to the command window. And remember, you see that I haven't wrote here the semicolon. Why I have done this? Because if I don't have the semicolon, the result is going to be printed out. Do you agree? So what you do is you simply type the name of your program, my cash flow 26, and just simply run. Here you go. 823.18. Do you remember the same result? Can we test this with a different cash flow? Remember we had this cash flow. Yeah, this is the last one, right? What I will do is I will copy this one here below. And what I will do is I will comment out this guy here. Should run, right? So again, I simply call the name of the program, different data set inside, 3,122. You see, guys, what you have done is you have created a program that does whatever you want. I will do more in a couple of minutes. Just let's make this more sophisticated in a couple of minutes. But are you able to find these results?
Sorry, do you mind scrolling up? So I saved it and everything, but I typed in my cash flow and it did not work.
Oh, be careful. Where have you saved the file? You need to do CD. Just do
Yeah.
CD, and you need to save your files in this directory.
Okay,
In your directory. I don't know what is your directory.
got it. All right.
Okay.
So, oh, yes, okay.
Okay, try. I want everyone to be with me here, guys. This is your first program, and you want to see how beautiful the programs. You can change, you can add, you can multiply, you can do whatever you want with these programs.
Wait, Dr. Yu, sorry, do you know, if I want to save it in a different folder, like I made a separate folder, is there a way to change your directory
Yeah.
again?
Just type, you can type this one here, whatever you have. So you do CD and then type your, I think you need to do this one. Yes, you need to do this way. So this one here, you need to replace with where you want to have your programs. Okay, so if you want to tell MATLAB where is your working directory, you need to do the CD apostrophe where your data is going to be located, your data, programs, and everything. So for this class, I created this one here, Summer 2026 Programming MATLAB files. You can create your own file. Is everyone able to run and see these numbers, guys?
For the new
Bafana-
cash flow, you just put
Oh,
in
just
like
put it
CF.
here and replace the. I didn't replace. I simply put it down below the original one, and I commented out the first one.
Got it. Okay, thank you.
Okay, ready? Are you with me, guys? Everyone? Okay,
Yes, Prof.
so what is interesting, guys, is that normally the programs do not have the data inside the program. The code is code without data. Do you agree? So imagine I want to change the cash flow, I want to change my interest rate, I want to change anything. Then what I want is this to be inputted from outside. Right? It should be coming from outside. At this point, as soon as we don't have worked yet with loops, I will do something simple. Let's call this one here big one. And then let's parentheses. When you do the parentheses are your input arguments. I want someone to give me the cash flow. Okay, someone is going to give me the cash flow. Well, also someone is going to give me the interest rate. And perhaps also someone is going to give me N. So these are the inputs that my program is going to request from someone that is using this program. And also, I want my program to return what? I want my program to return this one. Well, the name is not very useful, right? But I want this to be my output. My program is going to capture this information, is going to do all the estimations, and is going to estimate this one here, and this is the one that he is going to return to my client. And I can put now a semicolon. Okay, let's save this. Save as again with a new version. So you keep the previous, so you can track and trace what we're doing, how we're improving this stuff. Okay, now I don't need the data, so I can comment this out. Right click, comment. And then someone that uses my program needs to be sure to provide me with all this information. So let's assume he needs to provide you with, I have CF, give me 1 second. I need to check, do I have CF already here? Yes, I have CF. Do I have I? Yes, and I have N. Yes, I have all the information. So basically the user, that I'm now the user, needs to have all the inputs in order for the program to run. Got it? So how this person is going to run, I can put this, whatever, D equals, so the name can be different to the name here. It doesn't matter. I will call your program. I have my cash flow already defined. I have my I and I have my N. And then I simply run. And what the program is returning something that I call D. Oh, there is a semicolon I haven't used. Here, semicolon. I don't need this. Guys, do you understand what I have done?
Did you put the cash flow I and N again?
Yeah,
Like you
yeah.
just okay.
Yeah, the cash flow is something that I have created before. Okay, I have my I that I have created. So, but basically my cash flow, the one that I'm using now, guys, is this one. I have in the command window for now, I have created CF, I, and N here in the command window. So once I have all the information in the command window, so the command window, guys, later can translate into TXT, CSV, Excel, whatever file that you want. Got it? But it's external to your program. Your program simply does coding, uses data from somewhere, computes everything, and returns results. That's all. Make sense? Okay, so can you run your program with this cash flow? I will call this cash flow 1, and it's going to be equal to, cash flow 1. So what is happening now? Oh, I'm in the, sorry. I'm destroying my program. Yikes, what I have done. I need to go back. Yeah. So let's do cash flow 1. I'm in the, take a look where I am looking, guys. You see where I am? I'm in the command window. So I want you to run this your program on these numbers. So this is my new cash flow. I want my monthly interest to be 3% now. And I want N to be, I don't know, 14, whatever, because we're not using N technically in this point here. 1, 2, 3, space here. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. Yes, we're not using N, is useless, but in any case. So this is my new data. Can you run your program and tell me what is your cash flow at the end of the 15th period? I can call these guys I1, whatever you want, and I call this one N1, just to differentiate from the previous one. Someone can give me the number.
I got 3,856 and 16 cents.
Okay,
Yeah,
Yeah.
that's what I got as well.
perfect. So this is my cash flow. What I need to do is cash flow. I call it cash flow 1, I1, and 1. Do you agree? That's the data, correct? Now, guys, what is interesting, please pay attention here. The names that you have here can be different than the names that you have here. Even this one here. However, you cannot change the order. So for example, I cannot put the cash flow in the third position because MATLAB is going to understand that the third position is N, not the cash flow. So the order matters, not the names. Makes sense to everyone? Okay, so let's do this. 3,856.16. Beautiful. Do you see this, guys? Later, this program is going to be implemented in terms of not only in future values, but also in present values. You can change the input I, cannot necessarily be 2, 2, 2, 2, 2, can be 2, 3, 4, 1, whatever you want. Got it? But I need more commands for you to learn to change to replace this period here, this part here. Make sense? Okay, everyone is running. Are you running your first program? Perfect. Great. So let's continue doing, guys, a lot of more things that is going to allow you basically now to start building up programs. In economics and finance, guys, I will do more examples, but what we need to focus also is in printouts, plots. Okay, let's work with plots very quickly. So let's do simple plots, guys. For example, I want to plot the sine cosine function, etc. So let's define whatever. So let's say x equals, I will use linspace. Do you remember linspace is what? Linspace. I want to go from 0 to 2 times pi, and I want 11 observations. So remember that linspace is also sequence. It goes, the grammar is from up to where, how many observations. That's all. Then I will compute y equal sine of x. And then I will plot x comma y. So this is the way you do plots, guys. Do you see my plot doesn't look very smooth? Why it doesn't look very smooth? Because I only
Because of
have...
Not
the
enough in observations.
Yeah, exactly. I have just 11. So what we can do, guys, is we can simply shift this one here. Let's change to 100. Then I plot my, sorry, y, and then I plot this one here. Now it looks beautiful, right? Okay, so that the command is always plot x comma y. And then if you want to know all the things that you can do, colors, shapes, etc., you just do help plot. And then you have all the instructions to work with plot, guys. We're gonna continue working with more. But you have colors, you have point circles, you have solid, dotted, etc. We're gonna use several of them in a minute. Okay, are you with me? Okay, so now let's create, so I have y, let's create z equals cosine of x. One thing that you need to remember, so I have this screen already open, right? Now, what happens if I do the plot x comma z? It will destroy the previous one. Do you see that? So if you don't tell MATLAB, I want to create a new window with a new figure, MATLAB is going to overwrite in the existing one, in the active one. Got it? Okay, so let me show you, let's plot again the plot xy. And I want to create a different figure to plot cosinus. So what do you do that? How do you tell MATLAB, open a new file? Simply type figure, and MATLAB creates immediately an empty figure. And then you do the plot XC. So now we have two figures. And let me move this somewhere here. We have to. Make sense? So now, what if I want to put both of them in the same one? So there are two ways. I will create another figure. And what I can do, guys, is I can do plot XY, plot XC, and I want this one to be blue. So always MATLAB reads in pairs plus the arguments. So I want to plot first XY. In the same graph, plot XC, but now write it blue. Oh, blue, like that. It's a text. Do you see that? Now, there is another way. So let me create a figure. So let me plot the simple, this one. So now, guys, assume that you already have this created. And then you want to continue printing or making graphs on the same existing graph. So what you do in MATLAB command is you simply say hold on, and then you do the second plot. Plot, where is plot? This one here, and I want this to be red, for example. And I want to have like that. Do you see? So the MATLAB command here is hold on to keep it, and then you continue graphing in the same graph until you say hold off. When you say hold off, so basically it's not going to continue graphing in the same graph. Are you with me? Yep. Okay, guys, can you plot? Do you remember the unit circle? Guys, remember unit circle? Every time we use unit circle, when we do dynamics or econometrics, stationarity of the series must lie outside the unit circle. So what is this unit circle? Well, can you plot YC? Oh, this is a famous unit circle, guys. It's simply the combination of sine and cosine function. Do you remember, guys? Do you remember when we did seasonality in econometrics? We can use the sine and cosine function, okay? But we can do the sine cosine function can be the frequency can be longer, can be faster than having the normal cosine function like this one, or sine function like this one. Can you draw? Let me open. Let me save this for sure. Let me open a new one. Okay, can you draw? Do you remember sine square of x plus cosine square of x equals what? Do you remember this? 2,
Equal 1.
yeah, equals 1. 2 sine of x cosine of x equals sine of 2x. Can you take a look to this one? Can you plot these ones here? Plot sine square of x plus cosine square of x. how do you close all your graphs, guys? When you want to close all your figures, is close all. Okay, when you have a lot of, and this is very useful when you do a lot of programs and you want to see a lot of figures. And then remember, figures use space, got it? So you want to be cleaning the figures. So when you want is close all, and all your figures have disappeared. You see? There are no figures anymore. So if I want to plot, what I wanted to plot is x with, no, it is y squared. This is sine of x squared plus c squared, correct? This is sine squared plus cosine squared, correct? It's just, here you go, the full one. Can we plot? I don't need to keep this one here. I will plot now 2 times, sorry, 2 times sine of x times cosine of x. Two times, yeah. Can you plot on top of this one here, the sine function, red? I don't want to disappear this one here. So I just want the sine function to be plotted in the same graph, color red. So I need to do the hold on, correct? And then I can plot x and y. And I want this to be red. You see? So what we have done, guys, is simply the frequency is this is the 2 sine of x, and the other one is the sine of x. Got it? So you use this type of functions, guys, to model stationarity, not stationarity, seasonality. Now, we can add also to that one, we can add something that is called y label. So I want the y label to be, I don't know, y variables. No, independent variables. These are names only. I want, no, sorry, the y label is not independent. So I can call it dependent variables. My x label is going to be my independent. And then I can do a title. These are simply names, guys. You can type whatever you want. And then what I want you to observe is this one here. The title, my y label, my x label. Make sense? Are you with me? Okay, 2 minutes to copy or ask me questions, guys.
Dr. Eve, I had a question for the labels, just for presentation purposes. Are you
Yes.
allowed to like format like the font of it or like the sizing
Oh,
and
yeah,
then?
yeah, yeah, yeah. Yes. You go edit, and then here you have a lot of things.
Okay.
Okay. Now, one of the things that is crucial, guys, when you have these figures, the best format, of course, you want to put this into in your LaTeX or Word document as part of your report. The way you save it is very simple. It's save as. But just a recommendation here, guys. When you want the figure to go to your LaTeX or, oh, sorry, not this name. You put the name later. When you is EPS, this one here, EPS is complain is it works very nicely with PDFs, LaTeX, etc. Now, if you want to go back to your figure and open this in MATLAB again and change the data, change whatever you want later, you need to save it as .fig fig. Make sense? If you save this as an EPS, MATLAB is not going to open this anymore because it's a picture. If you want to keep the figure to be an editable one, just the .fig. Make sense to everyone? Make sense?
Yes, Dr. Eve. Thank you.
Perfect. Now, can you
Can-
please, guys, open a new figure, plot the sine and cosine function both together? And perhaps we can do this red. Do you see that one? Sometimes, guys, what we want is to add a text. I know that the blue one is my sine function. So I want to write here next to this one here. Let's close to, let's say, around 2.5, 2.5 and 0.7 around this point here. So that you see the coordinates, right? More or less I'm saying 2.5 and 0.7 should be around this part here. I want to write here cosine of x. You understand what I'm trying to do? Normally, when we do graphs, we try to put some comments on the same graph. So in order to do that, guys, what we do is going to be text. I say 2.5, 0.7, and I want to write sine of x. So this here depends on the figure. And text, you see?
Well, let's say like I plotted it and it was like wrong. How would I move that?
You cannot. You need
You
to,
can't?
to
Oh,
do it
okay.
again. Yes, yes.
Okay.
There is yeah, but it's very simple. Once you have the program, I mean,
Yeah.
once it is in an M file, you can change it. It's extremely simple.
Okay. Yeah.
Right? Yeah, because remember, guys, I'm using a lot the command window because it's fast and to check. But at the end of the day, the goal is you to build M file. So remember, an M file is what we have done. My cash flow 26. That's the M file. Okay, so you see lines of code, and then it's very simple to modify the lines of code as you want. If you make a mistake, you go back to the code, run it. It's very straightforward. Now, there is another method, guys, that is called gtext. Can you type gtext and then let's type cosine of x? Are you with me? This is another command. Yeah, we can do this now. Where is my MATLAB? Are you with me, guys? Just enter, and you see that it calls a figure, and then you move. It appears for you like that. And then you simply, well, I want the cosine function to stay here. Sorry, my text to be here. Once you select a position where you want to be, simply click and up. Got it? And then you can write whatever you want. I use this a lot in my papers when I want to stress something that is particular that you need to pay attention here. You know, there was a crisis here or something like that. Simply type whatever you want and you put it wherever you want. Make sense? Okay, so now let's go into a couple of graphs that are very useful for financial analysis. I sent you today, guys, a file that is called class 2 help something. Can you open that? Let's go to high, low, close chart plots. Are you with me? Okay, so can we load this one here, please? Just copy, you can copy basically all this part here. And I will explain what this one does. Load. This is a MATLAB file, guys. The simulated stock.mat is a data set that MATLAB has created for examples. And then you can take a look to whose, and then you can see which variables do we have, or you can go to your workspace here, and there will appear all the variables that we're going to be calling here. Then it has a lot of rows. So what I'm doing simply is the first 25 rows of information. And I want to use the MATLAB command is high-low. This is my data, and I'm using B, blue. And my title is going to be high-low, open, close chart, etc.
Excuse me, Professor. When I try to do load simulated stock, it does not like. Am I supposed to be in a certain directory or folder?
No, this is a MATLAB. It is a MATLAB created file. Do you have that, guys? Have you?
Same. I have the same error as Lauren.
Yeah, I'm just guessing it says error using load is what I'm getting at.
Yeah. Do we have to
So
install
you know
load?
what? Yeah, perhaps you don't have this one here. So what I will do is I will send this to you.
Mhm.
Okay, I will send this to you guys. But let's go through the process, and you're gonna do this later. Okay. So the MATLAB command is high-low. That's very. So what? Wait a second. So what version do you have? 2026?
Yeah.
That's weird. You should have it. Uh, yeah, it is. It is in a financial toolbox. Mm. Are you sure you cannot load this one here, guys?
No, it comes up as an error.
Yeah,
Should we
let
download
me.
the financial toolbox?
Yeah. Oh no, you must have it in your what you have downloaded. Can you please, guys, try to go into your financial toolbox? Not now because we are running out of time. Go to your financial toolbox. So where your MATLAB is located, and they have a lot of toolboxes. Okay, and then you check in the financial toolbox, and then you find this file should be there. It's very interesting. Okay, later you do that. Let's continue moving on here. Otherwise, I will send this to you. So what is going to appear, guys, is this one here. And I want you to read this one here because it's finance. We use this a lot. This graph here is known as the high-low open and close. So what is the low? So let's take a look to the first one. The low is the minimum value in the bar. I'm just taking a look to one bar. The low is the minimum. The high is the maximum. The highest, the tallest part of the bar. The open is to the left and the close is to the right. Make sense? So why this information is useful, guys, for a couple of things. First of all, gives you the volatility of the day and gives you, if you have an idea, you can have an idea if it was a bear market or it was a hawkish market. Make sense? Make sense to you guys?
Yes.
Now, what
Yes,
we can do
prof.
also, guys, is the Bollinger Bands. Where's my... Yeah, you cannot do that because you don't have the data, but you have the Word document. As soon as you get the data, you can rerun this too. So I'm creating the Bollinger Bands. And what is the meaning of the Bollinger Bands, guys? This is for trading. Yeah, the traders use this a lot. So this is the moving average. The blue one is the moving averages of the last 15, well, in this case, it's daily data, the last 15 days of trading. You can modify that. You can do the 20 days of trading, 30 days of trading, 1 week of trading, etc. Got it? And what is the upper bound and the lower bound? The upper bound is 2 standard deviations of the moving averages, and the lower bound is 2 standard deviations below the moving average. Make sense? And once we start building portfolios, guys, in 2 or 3 classes, you're going to see how useful these numbers are because this is used for technical analysis. The people that does technical analysis, the head and shoulders, strategies, when to enter, when to close, when to exit the market, uses this type of tools. Got it? So the open, close, high and low, the Bollinger Bands are extremely useful. Now, another one that we have is the candle plots. It's the same data set. Where's my MATLAB? My candlesticks. Guys, here the colors matter. So if we have a white color, so this implies that my day started, my opening was lower than my close. So take a look. Let's take a look to this one here. Do you see where my mouse is moving? Okay, so the lower part is my minimum value. The upper part is my maximum value. I have a white bar, so this implies that my open is below my close. Make sense? Take a look to what happened with the blue one. My minimum value, my maximum value. So what is my opening price here? It's a blue. So this implies that my opening was higher than my close. So in this case, this is my open and this is my close. Make sense? Guys, make sense?
Yes,
Yeah.
prof. Makes sense.
Perfect. Okay, so now let's go and see. Also, guys, when we do something, when we do papers, for example, so we have you seen these multiple plots, 4 plots, 6 plots? This is what is called in MATLAB is called subplotting. So let's do the following, guys. Let's go back to my X. So what I want to do is I want to have 4 graphs, 1, 2, 3, 4, in a single figure. So let's call X was 1. Yeah, let's call X again. Let's call Y. And let's do, where is C? I'm sorry. Let's do C. And then we can create, what else we can create, guys? Let's create Q equals 2 times Y times Z. And let's call Q1. I'm creating the 4 graphs that I want to put there. C1, let's say Y square plus Z square. So I have 4 figures. I can create 4 plots. And I want these 4 plots to be located 1, 2, 3, and 4. Okay. The first thing that I need to do is I need to create something that is called my subplot. I need to tell MATLAB, create a subplot. Okay, how many dimensions is going to be my subplot? Well, it's going to be a 2 by 2 and 2 rows. No, sorry. I just need 2, 2, and I want 1 figure. Okay, so what I have done here is I told MATLAB I want to create a 2 by 2. Now, the first position for MATLAB is going to be always top left, top right. Once you have done the first row, you go the bottom left, bottom right. Do you see? It's like a C. So this one here, it immediately opened. I don't know if you can see this here. Yes. You see this one? I have told MATLAB, in total, I will have 2 by 2. In the first position, please graph. Okay, then I want to graph here, plot XY, for example. You can see it created the first plot on the upper right-hand side. Now I want the second position to be my cosine function. And then you continue. So let's do your third position to be Q, and your fourth position to be your Q1. Here you go. So this is useful, guys, for you when you do papers or you want to organize your data. Questions about the subplots?
How would you deal with like on your subplot it has like 0.09999 like all that
Oh, you just need to change the
junk?
formatting. Yeah, the
Oh, okay.
formatting. But remember, that's the pain with MATLAB. MATLAB is
Yeah.
too precise. You see that we don't want to be too precise. We love just a column is just 2 decimals. That's it. Where are
And
you,
then
Trevor?
I'm by the Oculus. I just outside of work.
Oh, nice. Wow, nice.
And then it seems like we just need to do like an add-on for the financial toolbox.
Yes, that's all we need to do. But it is part of the installation process, so you should have it. Okay, just take a look and be sure, because finance is what we remember. This class is a financial application, so you need to have that toolbox for sure. Okay, guys, let's do a couple of other plots that are important for us in economics and finance. One of them is let's do I will do subplot 1, 1, 1. So this implies, okay, I'm done with my subplot. I'm just going back into the regular plotting. Got it? And I will do X is going to be minus 2.9. Let's go increasing by 0.1 up to 2.9. So I'm creating another x. And what I want, guys, is y equals the exponent of x minus x times x. Do you recognize this functional form, guys? The exponent of minus x prime x is x minus mu over a sigma squared. Looks like the normal distribution. This one here is going to create the Bailey-shaped function. Okay? This is a very, very famous function. You don't need to memorize these formulas. I simply understand what we're doing. So now I want to do is the var of x and y. This is one command that you need to know, is var. Here we go. You see the base shape? Got it? How do you create this? With var. Another graph that is also is the same stuff, but a kind of fancy. I don't know. I never use it, but I know it exists. Stairs. Make sense to you? Now, of course, what we can do is we can do a histogram now. So let me define x is okay. Let me define y as a random normal. Another command for you guys, rand n. This is going to create random normal variables, and I want to create 5,000, 1. So it's going to be 5,000 rows, 1 variable, randomly selected. Okay, but this is going to be following a normal distribution. Now, what we can do, guys, is hist. Hist is a command. But hist goes, what is interesting, guys, is we just write y and my beans. My beans are going to be defined by x. It doesn't look very normal, right? Even though that the numbers are randomly generated as a normal distributed, you can see that the history doesn't look like really like a normal one. So why is that, guys? Why is that? Do you remember this famous thing that happens? Do you know that if I flip a coin, head on tails, what is the probability of having a head?
50%.
50%. Do you agree? Okay, so what I will do is the following. I get head, I have my coin, flip it. Tail. So this implies that the next one should be head, correct? Yes or not? It must be head.
Is this leading into the law of large numbers?
Exactly.
Okay.
Guys, in real life, no. If I have a head, it doesn't mean that the next one is going to be a tail. Is it possible that in 10 trials, I have 10 heads?
Yes.
Is it possible? But come on, guys, but you told me that it's 50-50, so I should expect to have 5 and 5. So where the 50% comes into the game? This is the famous law of large numbers, guys. You need to do this experiment thousands of times, and you're going to get closer to the 50-50. Got it? So in terms of this graph here, implies that if I don't do 5,000, I do 50,000. So my distribution is going to be looking more and more like a normal distribution. Make sense to you? So this is the famous law of large numbers, guys. Questions? Good? Okay, so let's do some 3D, and then with that we stop. Can we go back to the... Can we call this again? Let me call these ones here again, just to be sure that I have them. So I have panel data, correct? So panel data was income and all this stuff there. Where's my... Okay, so this is my data. So let me define x equals 1 to 3. just my three individuals. So X is going to be my individuals. I have income and I have savings, correct? So X for me, guys, is going to be my number of individuals. So now what I will do is I will plot. So 3D plot, guys, the command is plot 3. What do you want to plot? Well, I want to plot X, this is my individuals, and then I want to plot income, and I want to plot savings. So in a single graph, I want to see per individual, what is the evolution of income and what is its evolution of, how do you call it? Savings. What I can do here, guys, is I can do X labels just to identify what I'm doing. X label is individual, right? Individual. Then in the Jesus. Then I can have my Y label. My Y label is going to be what? Income. And my Z label is going to be savings. So plot 3 is my command. What are the three variables? My X is going to be my individuals. My Y is going to be my income. And my Z is going to be my savings. Make sense? Are you with me? 1 minute to copy and then we continue. Guys, can you take a look? Works for you or not?
It does, but I don't think it looks right. Like I have, yeah, I don't think
Yeah,
it
let's
looks
take a
right.
look. Let's take a look. Yeah.
Yeah, like I
Everyone?
have 3 lines. I mean,
Yeah.
5 lines. I don't know.
Okay, so let's take a look to this. You don't get something like that?
Oh, I do. Okay, good.
Yeah, so you know what? Let's add
Yeah,
something.
I do.
Yeah, can you do grid on, guys? It helps when you have a 3D, normally it helps you to visualize better. Okay, a couple of things here. Where's my... I can rotate this one here. You see how I rotate? You see, guys? If you just put your cursor in the figure, just start moving the mouse. And it will move. Now, do you see when there are inflection points? Just put your cursor there and then you can see. What is this meaning here, guys? X2, 97, and 43. This is individual number 2, correct? Has an income of 97 and savings of 43,291. So if I can go here, individual number 1 at the end of the period has a salary of 425K and savings of 354K. Do you understand this graph here, guys? Okay, so there is another thing. Can you copy this one here? And instead of plot, just type mesh. Take a look to what the mesh looks like. The mesh simply, because the other one has a, you need to be looking right where the third individual and the fourth individual and the third individual works. So here is clearer. You see that there is a line here, there is a line here, and there is a line here. Do you agree? So that the way you read it, all this line corresponds to individual one. So this is the evolution of his income this way, if you read this way, and its savings that way. So you can see that the individual number two also increased on savings and income, but it was nothing comparable with this guy. And the individual number three, he also has an increase on salaries and savings, but nothing compared with individual two and nothing compared with individual four. Make sense? So this mesh helps you. And there is one more that is called surf. Surf. A little more fancy than the other one. Make sense, guys? Okay, questions? Okay, guys, you have your assignment number one. It's not for Wednesday, it's for next week, for next Monday. Okay, we're gonna do a lot more, but if you can be working with that, it's okay. There is one topic that I haven't covered in this class that is called annuities and amortizations. We're gonna do that early next week. Now, the only thing that I want for you guys is I will send you one example. Remember, you have computed your first program, your cash flow. Okay. So what I want from you is the following. Let me go back to my paint. So this is for Wednesday. For Wednesday, what I need is the following. Using your cash flow example, okay, create a new file because we need more tools to modify the existing one. Create a new file, new M file. And the only thing that I'm asking you is the following, guys. This is my C0. 1, 2, 3, 4, 5, 6. Imagine that here you have 2,000. You have here 1,500. And then you have here 1,800. Imagine that this is 2%. Okay. So what I want you to tell me is, what is this one here? Using the matrix way. So instead of compounding, going to the present to the future, I want you to go from the future to the present. Make sense? What you need to be very careful, guys, is simply your timing, your power per period. That's the one that you need to be very careful. And that's all. Guys, make sense? So I want your M file. So in next class, I will give you one cash flow, and you run and then you tell me the values. Make sense here? Now, next class,
Yes.
we're going to do amortizations, guys. That is very useful for mortgages. Okay, how mortgages work and cash flows, when do you pay early, etc., etc., etc. Okay, guys. So we stop here. Do you have questions?
Can we use like a sample cash flow from like what we did in class to check our work for this?
Yeah, it is here.
Okay,
This one.
cool.
This
Yes.
one here. So you copy this one here. So
Mhm.
your cash flow basically is going to be your cash flow. Where's my mouse? Oh, here we go. So your cash flow, guys, is going to be 0, 0, 1,800, 1,
Oh,
2.
okay.
Yeah. Do you see 0, 0, 1,500, 0, 1, 2,000.
Oh, we're bringing it back to the present. You're right. Yeah.
Yeah,
Thank you.
we're moving the reverse.
All right.
And
Thank you,
later,
Lauren.
guys, once we have more tools, next class we're gonna have more tools. You gotta be able to create a single package that does everything. Okay?
Mhm.
Make sense to you?
Yes. Thank you.
Perfect, guys. So see you on Wednesday. Have a good night.
Thank
Good
you, Professor.
night.
I
Good night.
Bye, guys.
Take
Good
care.
night. Take
Bye-bye.
care.